My name is Alessio TREBBI and I am a PhD candidate at the University of Grenoble Alpes under the supervision of Yohan Payan. Since its beginning on planet Earth, life had always to face a constant fight against gravity. If you think about it, life started in the oceans where the impact of gravity is much lighter, and only after a lot of effort, creatures managed to get outside the water. Even today, we constantly have to fight against gravity from the very first moment in which we wake up from our bed. But also during the day, there is this very strong force that pulls us to the ground, creating a lot of issues on our bones and compressing our soft tissues. Pressure ulcers can be explained with the example of an apple. If we let an apple fall, the force of gravity will pull it down, and in the impact with the ground, there will be a region of damage that we can call the pressure injury. This localized damaged tissue will keep growing if we don't eat the apple right away, and at one point will make the whole apple expire. Pressure ulcers work in a very similar way, but in this case they create damage on the soft tissues of human beings. In fact, when we have a constant load applied on the surface of the skin for a long period of time, some tissue might get damaged, and this damage can keep growing if it's not properly treated. Pressure ulcers can start in mainly two different possibilities, either from the surface of the skin towards the deep layers, or from the deep layers, so around the bony prominences, until the surface of the skin. In this second case is much more dangerous, as it's not possible to detect them early, and it's possible to find them only when there is a big portion of tissue that is already damaged. Pressure ulcers mainly occur in bedridden patients that are not able to move around, and therefore the bed surface creates very high loads and strains that will generate these sort of injuries. The most likely places to form a pressure ulcers are the heel and the sacrum. As this issue is strongly related to the biomechanics of the human body and the propagation of strains inside the soft tissues, researchers started to define some simulations to simulate the propagation of these loads inside the deep tissues of the skin. For these simulations, they use what is called the finite element method. That is the decomposition of a complex geometry as a foot in a lot of tiny pieces, and go to analyze what happens in every single of these little pieces. And probably the strongest challenge in these kind of simulations are their validations. So demonstrate that what you are simulating is actually what is really happening in the reality. A possibility to overcome this issue could be using what is called magnetic resonance imaging to analyze and track everything that displaces inside the human body. So a possibility would be to take an image of an unloaded tissue and an image of a loaded tissue, and then find out the transformation that there is between these two images to find out the displacements that occur when we apply a load. From the amount of force applied on the surface of the skin and the amount of displacement that is generated, we can extrapolate the material properties of these tissues, and therefore gain insight in the propagation of strains that would generate pressure ulcers. This technique is giving the expected results and seems to be promising, and to bring its own contribution towards the definition of proper and validated models of the human body to solve problems as pressure ulcers, but perhaps will be also applied in other regions of the human body to estimate and to solve problems related to these areas.